Okay, so this is the last part that we're going to go through today. So we left off at question 17a. So we're going to go through question 17b. This question 17b. So z equals to 1 plus 2ai, where a is a non-zero real number, the complex number, w is given by rei theta. Okay, so let's do part 1 first. Given z, the power cube is real. Find the possible values of z. Okay. So we know for a fact that if z the power cube is real, it means argument of z cube equals to k pi. Let's remember that we went through already earlier that the four cases. So in this case is k pi. So 3 argument of z equals to k pi. Possible values of z. Interesting question, because normally they will ask you for like, yeah lah, I'm sure you know lah, they will ask you for like the value of n, but in this case asking for the possible values of z. So that is kind of interesting. So lemai. So maybe let's look at the argument of 1 plus 2ai. Oh, but a is a non-zero real number. A complex number theta equals to rei theta given as theta cube is real. Find the possible values of z. Okay, I suspect, right, we need to, do we need to expand here? I'm considering whether we need to expand the function z. Yeah, I was thinking maybe we just expand first. So we know z is 1 plus 2ai. So z cube equals to, so you guys have to be familiar with expanding cubic equations. So equals to 1 plus 4ai plus 4a square I square 1 plus 2ai. Just make sure that z is correct. 1 plus 2ai. So not all the time really like you will get the answer immediately. You really have to sit down and kind of like really think, and eventually you'll really get it. So don't give up so fast. The answer is really within reach. 4a square minus 8a cube I. So 1, 2ai. I'm sure you know how to expand this. Just make sure it's correct. Minus 8a cube I plus 4ai plus 8a square I square. So let's simplify the terms first. 1 plus 2ai minus 4a square minus 8a cube I plus 4ai minus 8a square. Because I square is -1, as we defined it earlier. Let me just do a quick check that this I expanded correctly. 1 plus 2ai minus 4a minus 8a cube I plus 4a plus 8a square I square. Okay, so 1 plus 6ai, then so minus 12a square minus 8a cube I. So z equals to this. Okay, do you already see what the magic is here? Do you guys see it? So this is another way of doing it. So apologies for my approach earlier, it was actually wrong, but you can see how when we look at one approach is wrong, we got to find another approach that's actually correct. So assuming if my algebra is correct, I hope it's really correct, because z is real, right? Z cube is real. V1 z cube is real. Imaginary component must be equal to 0. So it means 6a minus 8a cube must be equal to 0. So now let's factor out 6 minus 8a square equals to 0. So we have a equals to 0, but we reject because a is really because a is, we already defined that a is non-zero, so a squared equals to 3 over 4. So a equals to plus minus square root 3 over 2. See, it's a nice number. So okay, we got the value of a. Find the possible values of z. So okay, so z is 1 plus 2ai. So z can equal to 1 plus 2 square root 3 over 2i equals to 1 plus square root 3i, or z equals to 1 minus square root 3i. Unless they explain that z is something different. So these are the possible values of z. So yeah, we got it. So z is this 2. So now we go back for the value of z for which a is less than 0. So we're looking at the negative one. So now they want z equals to minus square root. Z equals to what? 1 minus root 3i. Z equals to 1 minus square root 3i. So we want such that argument of p square over w power 4 equals to pi over 12. Find theta such that, okay, so we want to realize first that the expression is complicated on purpose, but it's possible and it's very well doable. So let me erase all this stuff first, because this is taking up a lot of the space. So let's make our working a bit simpler. So let me erase the whiteboard first. So remember that z is 1 minus root 3i lah. Okay, so let me just take a quick mental note. Z is 1 minus root 3i. Just keep it there just in case, 1 minus square root 3i. So z equals to 1 minus square root 3i. So we want argument of p square over w power 4 equals pi over 12. So we apply argument rules. Argument p square minus argument w power 4 equals to pi over 12. So now we want two argument p minus 4 argument w equals pi over 12. So p is zw conjugate. And we know that w equals to rei theta. Okay, so two argument zw conjugate minus 4 argument w equals to pi over 12. So we apply argument rules. Argument z plus argument w conjugate minus 4 argument. So you can see that it's just tedious. It's nothing really much to understand. Just that here, right? So argument of w conjugate is of just w. It's just negative of the argument of w, because I've already explained earlier why. So now for argument of w equals to pi over 12. So 2 argument of z minus 6 argument of w equals to pi over 12. So now let's find the argument of z. So because z is 1 minus square root 3i, right? IMRE. So let's find the argument of this. So we know that this is 1 minus square root 3 minus square root 3 and then we have 1. So theta, so tangent theta equals to square root 3. Theta equals to pi over 3. So we know that argument z is negative because we're looking at below. So 2 minus pi over 3 minus 6 argument w equals to pi over 12. So let me just do a quick check how to 2 bracket minus 1 over 3 minus 1 over 12. So 6 argument of w equals to minus 3 over 3 pi over 4. Argument of w equals to minus pi over 8. Find theta such that the argument. Oh yeah, then we found it lah. So theta is theta because argument w is just theta. So theta come minus pi over 8. So yeah, that's the correct answer. So let me just check whether it's the correct answer quickly. So I actually have the solutions popped up. Let me just make sure this is the correct one. I may be wrong, so yeah. Okay, so minus pi over 8 is the answer, but accompany it, there's actually a k pi over 3. So let me see what went wrong here. Hmm. Okay, wait, small intermission. Let me think about what went wrong here. Oh, because I know already. Okay, so we made a small mistake here because the thing is that um theta, right, can vary between pi and negative pi. So I'm looking at the answer right now. We actually need to add a factor of a plus 2k pi, where k is element of the integers, because so k can be positive and negative, so we don't know whether it's positive or negative. So what we are trying to do is that we're actually trying to like scale it by a factor of 2 pi, if you know what I mean here. Yep. So right, if we do the math here, right, we get that 6 theta equals to minus 3 pi over 4 minus 2k pi. Or we can just let it be plus because like k can be anything. So um theta equals to minus pi over 8 plus k pi over 3. So once we sub in the various values of k, right, so k equals to minus 2. So from here to 2, right, we get theta equals to minus pi over 8 uh 5 pi over 24, 13 pi over 24 minus 11 pi over 24, and lastly minus 19 pi over 24. So yep, so these are actually the values of theta. So I made a small mistake there. So yeah, so any questions? So just now the one the z to the power of 3 is real, right? Um why we don't need to scale? The other question, why we don't need to scale? No, because the for the other question, right? We are just we are not for this question we want no for this question it's not about scaling. There's for this question there's no scaling here. We just add the 2k pi because we just want the we are actually scaling. It's actually a form of it's actually a form of scaling, right? So for this part. But this one we don't need to scale because we are just finding the value of n such that the argument of w is real. The difference between these two is that because this one the value of theta the value of theta like kind of like varies um but like okay, so okay, my argument is not very convincing, but the short answer is that um theta is a constraint, but n doesn't actually have a constraint. I guess that's the only reason lah, because you already restrict theta to this, so you kind of have to add like a scale. So you have to add like a factor to account for this effect, and then w power n, right? The n can be anything, it can be further scaled later. So yeah, it's probably something like that. So yeah, good question, good question. I also didn't realize it myself, but yeah. So I guess that's the difference. So there's some nuance in mathematics that you have to like realize. So the more you practice, the more you'll realize this. So just my final thoughts is that these two are really good questions. So um good questions. And I think it was fun doing these two questions. And I think that we will end the walkthrough here. We will end the walkthrough here, and I think the next time that I will do a video will be after my prelims, because kind of want to focus on A level prelims right now, because prelims are gonna start. So maybe I'll do other videos like on like the other H2 math chapters, maybe vectors. I want to do it again properly. And so yeah, so do stay tuned for like other walkthrough videos that I will be doing. And yeah, I think that's about it. It's like 2 a.m. right now, so yeah, then we'll go sleep. So yeah, thanks for staying up with me if you're watching this at 2 a.m. If not, I hope this has helped you. So just a short walkthrough. So if anything, you can just text me, like just give me a quick text. I will like just reply as fast as possible. So if not, yeah, thank you and see you again.